The periodic table of elements is the cornerstone of modern chemistry, but in many ways it is based on the paradoxes of quantum mechanics. In a new theory, the paradoxes of quantum mechanics can be explained, giving us a deeper understanding of why we have a periodic table of elements. This theory is based on just two simple postulates. The first is that the quantum wave-particle function, or probability function, represents the forward passage of time, itself, photon by photon. The second is that Heisenberg's uncertainty principle, that is formed by the probability function, is the same uncertainty we have with any future event. This process of continuous change, or energy exchange, we see and feel as the flow of time itself, that we can interact with, turning the possible into the actual. This process is totally universal and interactive, from the largest object to the smallest creature, right down to the smallest element of the periodic table, will slow the rate that time flows, forming a curvature of space-time relative to its own energy or mass. In this theory, the elements of the periodic table are standing waves over a period of time. Time is continuously being formed by the spontaneous absorption and emission of light waves of electromagnetic radiation. This forms a universal process of spherical symmetry forming and breaking that forms the spiral patterns we see in our everyday life, with each element of the periodic table having a set position forming the curvature of these spirals. With hydrogen at the center and the noble gases and different groups of elements radiating out like spokes from the center of a wheel. In the traditional periodic table, there is a problem of where to place hydrogen and helium. They can be placed on the left-hand side because of their electron configuration, or they can be placed on the right-hand side. But by placing hydrogen in the center of a spiral, we solve this problem. Also, by having a periodic spiral, we place the groups of elements that can undergo ionic bonding together on either side of the noble gases. We have had many different types of periodic table in the past. In 1865, the English chemist John Newlands formed a periodic table where the elements with similar physical and chemical properties reoccurred at intervals of 8, which he likened to the octaves of Western and Indian music. This became known as the law of the octaves, but it only worked up to the element calcium. Newly discovered elements further down the periodic table would not fit into the octave structure. This theory can explain a reason for this. It is because the spiral symmetry is formed out of the broken symmetry of a sphere, and as we go down the periodic table, the spiral symmetry becomes more broken and the elements become less stable. Only in 3 dimensions can we see the true beauty and wave-like nature of the periodic table. Each wave forms a period with elements that have similar properties having a similar position within each wave.